In this video, we are looking at some important points about practical work. Here, we are looking at measuring the length of an object with a classroom ruler of about 30 centimeter length. Here is a picture of it, and we use centimeters here, not inches. And also you'll notice the smallest division here is 1 millimeter, and therefore the reading we take should always be in centimeters as a practice, and then round it to the nearest smallest division, which is 1 millimeter or 0.1 centimeter. For example, the length of a pen could be something like 14.3 centimeters. This is the millimeter. 0.3 centimeter means 3 millimeters. If we put down 14 centimeters, that's not quite accurate enough. We can do better than that. But if we put down 14.26 centimeters, that would be too accurate. We can't really read to the tenth of a millimeter. Raw data and calculated data. 14.3 centimeters, which is the length of that pen that we saw on the previous page, is what we call a raw figure or a raw datum. Datum is the singular form of data. If we use that figure for calculation, then the result we get is called a calculated figure or calculated datum. The calculated figure cannot be more accurate than the raw figure from which it is derived. For example, 1/3 times that raw datum of 14.3, which is the length of the pen, 14.3 here, is equal to 4.77. 3 sig fig, 3 sig fig, and it says here, which has the same sig fig as a raw figure of 14.3. In general, any calculated result or datum or figure must be to 2 or 3 sig fig. Reading a stopwatch. A typical stopwatch looks like this one here, with 5 zeros. It measures in seconds. So if you look at the face of the stopwatch, the first zero on this one here gives you seconds. The second zero is tenth of a second. Third one is hundredth of a second. We ignore the last 2 zeros. They are too accurate. So as a rule, we record times to 2 dp. For example, 8.32 is 2 dp. Reading digital multimeters. Here is a typical multimeter. It can be used as an ammeter, it's A here, or V voltmeter. And this one hasn't got ohm here, so it can't be used as an ohm meter. And as you can see, it gives 2 dp. So whatever it says here, just copy straight. Heading or headings of table of results. Before entering raw data in any table like this, the heading of each column must be completed first. Look at the first column. L stands for length, physical quantity, slash centimeters, that's unit. Second one, time in seconds. Current, I stands for current, in amps. Theta stands for temperature in degrees Celsius. Recording data. All the recorded data in any column must be consistent in number of dp. Look at this first column, length measure to the nearest millimeter, therefore 1 dp or 1 dp. The time, measure with a stopwatch, all in 2 dp, you can see here. And current in 2 dp. Thermometer, the temperature in 1 dp. But you'll notice here, all the data end in either 0.0, 0.0 or 0.5. That's because the thermometer reads to half a degree. So it's either 0.0 or 0.5, nothing in between. Important points about graphing. I've got 4 bullet points here for you to take note of. First one, use as much of the graph grid as possible so that your line graph looks big. Second point, choose a scale suitable for each axis, both the vertical and horizontal axis, that will make your graph occupy majority of the grid. In other words, don't just do a small graph. Third point, don't use such awkward scales as 1 to 3 or 1 square to 3, 1 to 6 or 1 square to 6, or 1 to 7. They are awkward. Don't use them. Lastly, always use small crosses like this for plotting points. Never use a dot like this or a big blob like this. Important points about graphing, page 2. Here you can see 5 points have been plotted using small crosses, and each cross is small enough to fit into a little square like this. And last point says you don't necessarily have to start from naught for any of the axes. Here, both axes start from naught, but you don't have to, as the next page will show you. Important points about graphing 3. Couple of things about these product points here. Firstly, there is a fair bit of waste of space here. So we don't have to start from 0. For the horizontal axis, we could start from 3. So 3 can be here, 3, 4, 5, 6, and so on. For the vertical axis, we could start from 12. So 12 can be here. Another thing is we could change the scale for the vertical axis. Here we have 1 division to 2. We could change it to 1 division to 1. That will make these product points spread out twice as much. Important points about graphing number 4. After the points are plotted, a line of best fit should be drawn. In physics, we don't draw connecting line. In other words, you don't just connect up all these points and you end up with a zigzag line. In general, judging by the trend of the plotted points, we either draw a straight line of best fit or a smooth curve of best fit. In our case here, it is clear that the general trend of these points is a straight line. So we draw a straight line through somewhere in the middle.